Sure. Questions? We're on for a question and answer session. Okay, 10 minutes. And and we have, oh, well, we're gonna, I think the first hand I saw, Heather, was.
Hello. Okay. I got a question for Jorge, and you said that at the moment in the Southern Ocean there's 44 floats deployed, right? Did you actually analyze for this year already data? Do you still, for 2016 now, the floats that are out there in the ACC region, is this, is this summertime outgassing this strong? Is this reoccurring, or is it something that you still have to analyze?
Probably a switch.
Allison sent to me this cumulative analysis. I didn't show that in my talk, but we've done these cumulative analyses versus time, which show, that your estimate and the floats are sort of accumulating at the same rate in parallel, except in the winter when ours takes off, and then they become parallel again. And so Allison sent me a huge, long, tiny images, which I didn't have time to look at carefully, but as far as I can tell, all of the floats seem to be accumulating more. So, yeah, within a year or two.
Yeah, no, I was wondering because that would actually show if it was a one-time event in 2015 or if it is something that is reoccurring.
Yeah, looks like it's accumulating, yeah.
Are there any plans to submit your PCO2 product to SOCAT, or does it not qualify because it's a product instead of a direct measurement?
It doesn't qualify.
I think there. Go ahead.
I think the answer is that for two reasons. So number one, this is new, so we need to work with SOCAT to understand how to include this. But SOCAT, for example, would not want data that they would say has a 10 ppm uncertainty in it, right? So this is, their target is 5 ppm or less, I believe. And yet on the other hand, the vast areas of the ocean where we don't know what the amplitude of the annual cycle is and so on. So there needs to be a way to merge these, but that bridge has not been crossed.
Lynn gave a really nice review of the zonal asymmetries in the ACC. Sorry, this is Andy Thompson from Caltech. And certainly for the physics, we know those are really unique areas. Are the floats going to be able to resolve whether there are differences in the biogeochemistry in those very compact regions?
Yeah, sure. The plan is that they will. We're at 50 floats now. We're going to 180. We're putting out 44 next year. So I didn't go over what goes into actually deciding where to put a float. We put a lot of work into it. So we're constrained by where there are ships, but once the ships are pretty circumpolar, we're putting a lot of time before each cruise deciding where to go and make sure we sample these distinct regimes. So that's the answer. It was a trade-off from the very beginning between being very concentrated in one area or being circumpolar. We went with circumpolar, so we'd have a coarse sort of scaffolding for the whole region. And then as people want to propose regional experiments, they can fit them into that. They can enhance or whatever. But our goal is to hit every regime. So on a cruise, I feel like I failed if two floats are correlated. Anyway, that's kind of the rationale.
Yeah, Lynn is being modest. I mean, the amount of effort that goes into planning these things is just extraordinary. There's all sorts of simulations run. The state estimation has also told us, given us a fair amount of information about where they should go. And of course, then there's her intuition, that is so really outstanding on this stuff. So I don't know if that answers your question.
We're trying. If you have a favorite spot that you feel is not being sampled, let me know.
Is the the CO2 system still running on the Gold, going back and forth across the Drake Passage every month? Because that's been going for quite a few years, and if it is, that would be able to tell you if the Antarctic zone was anomalous in the last 2 years.
Ken, you have an answer.
Yeah, it's still going, and we have a float about to go into their array, and it's generating data that looks just like their array. The real question, and Dave Monroe is around here somewhere in the back, could say more, but how, the question is, can we extrapolate from the Drake Passage line to the entire Southern Ocean? They have done that. But does it help to have more floats and more data elsewhere? Is the Drake different than other regions? We're basically gonna find out. But one of the things we really want to do are look at floats that go through the Drake, through the Gould arrays, and do cross lines, do intercalibrations with them as well. So as the number of floats goes to close to 200, this will happen more frequently. Right now, we're just early in the Gould array, I think, is like the one golden important, stake for the kind of stuff that we're doing. It's a calibration point that, we really need.
In terms of a global biogeochemical array, what are the requirements for calibration, and kind of what would change that offset you would have to make? Like, would it be regionally dependent, or how would you set up a program to make sure that all the arrays are calibrated?
Keep funding GoShip.
Yeah, keep funding GoShip. So go ahead, again, in my last slide or so of how this all ties together. So the work that Nancy and Lori Juranic have done, which shows that we can take the deep data and generate equations that interpolate, that allow us to essentially calibrate, check our sensors for drift. We have to carry that forward to the global ocean. We need the GoShip data to continually be updated so we can make sure our calibrations are correct. But ultimately, we free ourselves from deployment. Primarily, we deploy from GoShip cruises now. Yeah, it's the biggest piece.
The other half is the biggest piece of work for me, because it's not coordinated.
And so, we need GoShip to make sure that we have a good, deep calibration. We need to get away from the deployments strictly in GoShip, so we can deploy on cruises of opportunity everywhere, because GoShip just doesn't go everywhere. And
What's involved right now for that? I'm planning a lot of cruises, 7 cruises next year. I think 3 are GoShip, the others aren't. What's involved with those is measuring that laundry list. So we have a CTD, we want Winkler titrations of oxygens. We're hoping to get away from that because there are fewer and fewer people that know how to do it and that go to sea doing it. We like bottle salts because they help with bottle quality. And then we have to measure nitrate. I like full nutrients, but we're having to compromise and do frozen nutrients. So that means nitrate's the only one that's valuable. The others are dirt, which stink. Once they're frozen, pH alkalinity and DIC we bring back and run in the lab if we need to. HPLC and POC for the optical sensors, and that's our suite of measurements. So it's pretty intense.
I think another thing to point out is how much progress has been made on the pH sensor over the last couple of years. And I watched it in fascination. I mean, first of all, they figured out that you need to put the sensor in real seawater so it gets the bromine in it, otherwise that's a big source of drift. That these things dry out when they put, I don't make measurements, so maybe that's why I'm so fascinated by this process. But, you need to bathe the sensors. They sit dry on the shelf for a long period of time in the ship, and they need to be bathed for about 3 weeks or so in seawater before you put them in, or that you get that big bump at the beginning. The fact that the sensor, the first measurement is not made till 18 hours after the ship, they're dumped over the side of the ship, which means that the shipboard measurements are from 18 hours before, is an issue that has to be dealt with. And now we've been having some sensors that have failed, and these guys seem to have gotten to the bottom of what might be causing it, which is the dryness affecting the sealing of these things, right, Ken? So there's been, if you look at the first-year floats, as Nancy showed them, but there's been a huge progress through time, and our goal is to have that first measurement be flat right on the line, line and everything sort of bouncing around the zero line, so that we're talking, about instruments that don't even have to be calibrated ahead of time.
Ken? Oh,
Oh.
somebody else. Oh, Jamie.
This is, yeah, Jamie Falter from URI. Since so much of the value comes from the surface layer, and these are now profiling floats that go to 2,000 meters, is there any thought about possibly going to the surface drifters? I would think, to putting PCO2 or pH on surface drifters in addition to what you're talking about.
Well, yeah, I mean, biofouling, but the value of going to 2,000 meters is that we get a reference measurement, so if you put it on a mooring and the value changes, you don't know if it's the ocean changing or the sensor drifting, but in principle, the ocean at 2,000 meters is very stable, right? So we know what's happening with the sensors. So surface drifters are just a tough, it's a great idea, but it's a much tougher challenge. Yeah.
I guess we had a similar idea. I was thinking, have you really evaluated the frequency and the sampling, not even just 2,000 meters, but some locations and times? Isn't that why we're using the same deployment times and depths?
Well, I can tell you why we're doing it now, just because it's hard to change and you really can't manage. I mean, it's easy to kill a float. And just by, how you type the wrong number in and tell it to stay at the bottom for 10 years instead of 10 days. I mean, it's kind of, it sounds funny, but it's easy. So managing the float cycle time can be done, and we've done it. We've changed float cycle times. It's just that the software to do this easily doesn't exist yet. And so it requires people to put some significant effort in, and we just don't have the manpower right now. So we're sampling, we've gone to the least common denominator at this point in time. I will say that Argo in particular is trying to understand how they can make the array available, almost like ship time, that you could get cycles and change them more frequently if you wanted. Software, again, doesn't exist yet, but that's what we're heading towards, is if you were in front of a hurricane, if you were studying hurricanes and mixing, that you could turn the cycle time up. And that will happen in Nancy's lifetime, maybe not in mine, but that's the idea, that you could use the array much more dynamically. Right now, it's kind of old technology in that sense.
I think it's more that we're being conservative, because Dana Swift can do anything he wants with the programming on those. But as he said, he doesn't want to do the Watusi.
Yeah.
So we have deployed some of them with a shorter profiling time at the beginning, especially for our Australian colleagues, Tom Trull and Pete Strutton, who are deploying in eddies with their experiments. So we said, okay, fine, you're helping us a lot by putting these floats in. We'll do 5 days for a while. And Dana runs experiments with them for various reasons, because this is an experimental program. We're getting things ready to do routine. But he's the one that wakes up at 4 a.m. when something happens with a float, and he's the only one. So
Heather's given me this chop and others. We got one last from Will.
Okay, you made a very compelling case. As has been pointed out, these go to 2,000 meters. For the questions you're asking, what do you miss by not being able to go deeper?
Argo is starting a program to go to full ocean depth to 6,000 meters. For example, if you had an oxygen sensor, I remind Jorge that his PhD thesis was looking at the eddy diffusion coefficient in the benthic boundary layer. And if you had an oxygen sensor on the floats, you would see, statistically, you would find that oxygen's a little bit lower near the bottom, and you would start to get the sediment. Oxygen, Ken Smith would call it the sediment community oxygen consumption. Rick Yonke would call it the benthic oxygen flux, but it's the respiration rate of carbon in the sediments, as an example. It's tough. Well, that's just one example of the things you could do. There would be science there. It's tough because the sensor is, that's a big demand on the sensor to go full depth.
Okay. We need some transition time before we move on to the communication session, so I want to give our speakers another hand for a great session.